This is Chapter 4, Lecture 2. So we're going to move ahead in our notes and look for isotopes. Isotopes are atoms that have the same number of protons but a different number of neutrons. Isotopes are chemically similar to each other because they are the same atom. The difference is in the neutrons found inside the nucleus, but the protons and the electrons stay the same. So there are 3 isotopes of hydrogen, and it seems a little weird, but I think you'll get used to it. There is this isotope of hydrogen, which has an atomic number of 1, the lower number, which is the number of protons, but it also has a mass number of 1. We call it hydrogen 1 for the atomic mass. It also has the name protium, which you don't have to know. But in terms of neutrons, when you subtract the bottom from the top, it has no neutrons. But there's another isotope of hydrogen. It's called hydrogen 2, which is also called deuterium, which you don't have to know. Deuterium, when you subtract the number, has a neutron. So it's got 1 proton, the lower number, and 1 neutron, the difference between the two. And then there's a third isotope of hydrogen called hydrogen 3. It's called tritium. It has 2 neutrons. So each isotope of hydrogen has 1 proton. The difference is the number of neutrons. But if you were to look at hydrogen, you couldn't tell how much of it was hydrogen 1, hydrogen 2, or hydrogen 3, because they would all be found in there in different proportions. So in this table, we have different isotopes that we have to figure out what they are. So in the first one, there's 16 protons, and the mass number is 32. So we subtract to get the number of neutrons. The number of electrons always equals the number of protons, and the atomic number always equals the number of protons. But what is this thing? So we look up atomic number 16 in the periodic table, and number 16 is sulfur, and then the dash, and then its mass number. So this represents sulfur 32. What about the next one? If there are 20 electrons, then there must be 20 protons. The mass number is protons plus neutrons, which is 44. The atomic number equals the number of protons. And then its name, we look up atomic number 20, which is calcium. And then the dash is for its atomic mass, its mass number. So calcium 44. So go ahead, pause the video, do the next 3, and then come back. And check your chart against mine. So now we're going to investigate atomic mass. Unbelievably, the masses of atoms have been determined with a device called a mass spectrometer. So we know the mass of a fluorine atom. We know the mass of an arsenic atom. But who wants to go around stating that a fluorine atom has a mass of 3.155 times 10 to the minus 23 grams? So it's more practical to compare the atoms' masses to each other in a relative way. The reference for this relative value is carbon 12. So it's carbon with atomic number 6. Since it weighs 12, it has 6 neutrons. Since carbon-12 has 6 protons and 6 neutrons, we would expect it to weigh 12. Well, let's look in the periodic table, and what is the mass of chlorine? So chlorine in the periodic table shows an actual mass of 35.453. Make sure you look and see where that came from. Well, if chlorine is a bunch of protons and neutrons which have whole numbers, then why is the mass 0.453? And the reason is the mass in the periodic table is the average of all of the isotopes of chlorine. So we see here, chlorine has 2 isotopes, chlorine 35 and chlorine 37. The atomic mass of an element is the weighted average mass of the atoms in a naturally occurring sample. So if you were to take a sample of chlorine, 75.78% of it would be chlorine 35, and 24.22% would be chlorine 37. And I think that's all we're going to do today, and we'll do the math in class tomorrow. So have a great day, and we'll see you then.